All right, so in this particular video, what we're going to do is we are going to be using slope and intercepts in context. All right, so we have some word problems here. Just remember, whenever you guys are using slope and intercepts in context, here's what you're going to need to know. Ready? You got your old slope-intercept formula, which is what? Y equals mx plus b, correct? So now what is the m value once again in reference to m is always equal to our slope. The b value is always equal to the y-intercept, okay? And just remember, the y-intercept, the x value is always equal to 0. So I'm going to call it 0, comma b. That's not a 6. This is supposed to be the letter b, okay? Not a 6, just a b. So whatever x is, it's going to be 0. Your y value will be whatever the b value is. Now, does everybody understand that the x-intercept will be wherever the x value is, but the y value is 0. So can everybody see where the x-intercept is right there? That's the x-intercept. I'm going to label it. You don't have to draw this graph, okay? But you do need to know that the x-intercept is where the y value is 0. What is this guy right here? That's our y-intercept, all right? And then we have our slope. So this guy, this right here, this line tells us our slope. So what does our slope tell us without having to like interpret it? What does it tell us? It's going down, so it's going negative, right? All right, so it says students have a choice between taking a test on paper or on the computer. Okay, all right. You guys won't, I'm not going to give you choices. It'll either be on paper or it'll be on the computer. So this person's a lot nicer than I am because she's giving them a choice. Mrs. Ghazi graphed the relationship between the number of students taking the test on the computer and the number of pages she would need to print. Okay? All right, so let's see here. So let's think about it this way. Ready? Right here, let's say this point right there. Okay, let's think about that. So what would this point right here represent as far as students using a computer? There's what? How many students? 3. And like if we go here, that's 50, this is 60, 70, 80, so we're at what, 90? So basically, what would that point mean? That means if there's 3 students using a computer, how many pages is she going to print? 90, correct? So what does that mean for us? That means like literally, if there were no students using a computer, how many pages is she going to have to print? Way over 100. But if all of the students being what, 15, 16, 17, so she has a total of what, 18 students. If they all use a computer, how many pages does she have to print? What do you guys say? 0, right? So if all the students use a computer, she doesn't have to print any pages. But if 0 students use a computer, she's got to go, we'll just say, close to 110. I know it's not exactly at 110, but we'll just say about 110. Okay? So this one says, the question says, what feature of the graph represents how many pages Mrs. Ghazi would need to print if none of the students take the test on the computer? So would you guys agree this is where none of the students take the test? Right here? So what does this point here represent? What did we call that point? We called it the what? The y-intercept, right? That point represents the y-intercept. So we were going to call it Y-intercept. Okay? I realized I did a lot of extra stuff. Okay, well, why did I do a lot of extra stuff? Because what are you guys going to need to know about the graph? The y-intercept, the x-intercept, or is it talking about the slope? So it's going to be talking about one of those 3 things. Let's see what this one does, okay? I'm not going to do a whole bunch of stuff here, okay? But we're going to read through it, and then we're going to make our decisions. Just make it with me. We're going to do 4 problems, then you guys have the rest of the period to work on your own. Mio apparently is the doppelganger of Mia, but Mio bought a tablet and pays monthly for the internet service. She graphed the relationship between the number of months she had the tablet and the total amount she has spent on it. Okay? So right now, what is this right here? What's our x values? That represents the time, and the total cost is the money, right? So right here, what would you guys say this right here represents? Yeah, it's the y-intercept, right? So that, would you guys agree that's just it's slightly over Oh, not 100. Not bad, my bad. 100's right here. So just what? Slightly, that's close, just slightly over 50. All right. So she bought a tablet and pays a monthly internet service for it. So basically, anytime you guys see this point, that point refers to what's called a flat fee, or like an initial fee. All right. What's it cost per month? Well, that's your service fee per month. So let's see where we go. Oh, I like it. I like it. I see the answer. Okay, so check this out. What does this represent? This represents the monthly what? Internet service. And this is the total amount that she spent. So this is the rate of the internet service. What do you have to do before you get an internet? You got to buy an item, right? Ah, okay, you got to buy the item. So I think this is going to be the cost of actually buying the tablet. So it's a pretty cheap tablet. All right, maybe a Fire, HD. All right, does that make sense? So guys, what is this? What is this right here? The cost per month. What would that be? That would be the slope. And then you can also see if you mess up, it'll let you know which one was the X-intercept. Well, this one would be negative. All right, in this particular one. All right, do two more. Cool. Look at that. Stalactites and a column formed by stalactites and stalagmites growing together. Very nice. Cool. All right. All right. So, you guys see this right here? A stalactite and a stalagmite are growing toward each other in a cave. All right. So, do you guys see how they can be growing in opposite directions, and that's what they form when they grow in opposite directions? So, they gave you a nice little picture there. That's nice. The following graph shows the relationship between the time in years since they appeared and the distance between the stalactite and the stalagmite. So what is that saying? So imagine you got a stalactite and a stalagmite, and what are they doing? They're growing in opposite what? Opposite directions. Eventually, what's going to happen? They're gonna meet, right? That's basically that's what's being graphed right here. Okay. All right. So right now, it says what feature of the graph represents the what? The rate of change of the distance. Well, what are you guys thinking about the rate of change? What is that talking about? Slope, right? So this is the rate of change in the distance. So we're going to be talking about the slope. So anytime you guys see the what? Rate of change, what are you going to refer to? The slope. Okay, that's all. All right. All right, last question. Felipe put a bowl of candies on his desk. He graphed the relationship between how many days had passed and how many candies were made. So how about this? You guys ready? At 0 days, how many candies did he start with on his desk? Start with 32, right? All right. And then after 8 days, how many candies does he have in his bowl? 0. So all those students were like, snatching candy, snatching candy, snatching candy, all right? But what does this line represent? That represents the slope or the rate of change. All right? So what does the X-intercept represent in the context? That's how many days it took when he has how many candies left? Yeah. That's 8 days when he's got what? 0 candies. That's what the X-intercept. What does the Y-intercept represent? How many candies he starts out with? What is the slope? That's the rate that he's losing candies per day. So, by the way, let me make sure you guys understand how to find slope. It's very, very easy, especially when you have an X-intercept and a Y-intercept. So here's what I want you guys to do. In your journal right now, I want you guys to do one thing for me, and that's it. I want you guys to find the slope from the X-intercept and Y-intercept. This is about the easiest way you can find slope. So could you please title this? This is the one and the last thing I'm going to have you guys put into your journal. Slope from the X-intercept and the Y-intercept. So our Y-intercept is 0, 32. Our X-intercept is 8, 0. Literally, how much does that drop down? That drops down 32. How much does this go up? It goes up 8. Spray man, spray that guy's rack. Sorry, we have a disinfectant gel make sure we combat this pandemic. Thank you. All right. So here we go. What does this represent? This represents the change in y. What does this represent? The change in x. So what is our change in y over our change in x, even though they don't ask us for it? Negative 32 over 8. So what would our slope be? What do you guys think? If you had to guess, or had to work it out. Oh, nobody's paying attention. Okay, so it's just negative 4. All right? Negative 32 divided by 8 is negative 4. All right? Now, here would be your equation. You guys ready? And y equals mx plus b. This would be your equation for this particular graph. The slope is negative 4. And what was our y-intercept? 32. This would be the equation that matches this given situation. The reason why I'm doing this is, guys, I'm letting you guys know that this is what's coming. I'm going to give you graphs and word problems, and you actually have to find the function that matches the graph. So you have to know how to find slope. What else do you have to know how to find? The y-intercept and the x-intercept. You got to be able to build the equation. And that's it, guys. The rest of the period, you have a chance to work on all of these. You guys see how easy this is? It's not that bad. So what does the x-intercept represent? How many days passed before there were what? No candies remaining. All right, after 8 days, no more candy. I'm sorry. Boom, there's 100. Now you get it done.